Hey guys, welcome to the notes for discrete and continuous functions. We're also going to talk about the associated domain and range with discrete and continuous functions. Before we go over discrete and continuous, we need to talk about what a function is. So I have this Frayer model here. So if you have a sheet of paper, or if you'd like to take these notes on an extra, like on the back of your notes somewhere, if you have room. I think there's a section at the very bottom of your notes, so like right down here in this section, if you want to take the notes there, you may. But I just have function in the middle, and we're going to talk about the definition, the characteristics, examples, and some non-examples. So the definition of a function is that for every input, there is only one output. So for every input, there's at most one output. So that means when I put something into my function, the most I should get out is only one thing. So if I put a number in, I can only get one number out. All right, so some characteristics. We have two characteristics that we kind of look for, and they're separated into graphs and tables. When we're looking at graphs to see if it's a function, we want to see if it passes, or we want it to pass the vertical line test. And this might be something that you might have talked about in middle school. Your teacher might have called it the pencil test or the line test, but we need to be specific and say vertical line, because a line could face any direction. It could be a horizontal line, could be a slanted line, right? So we want a vertical line. So we want to draw what a vertical line looks at. That looks like this. And when we mean pass it, we mean only passes the line once. So you don't want the line to pass more than once. So just like a function, right? We only want it to pass one time. With tables, we are wanting no repeated x values. We basically don't want one of our x values to output two different numbers. And we'll talk about that in our examples and our non-examples. So, and I just want to highlight x values because we only really care, or we're looking at the x values. So an example, let's go ahead and take a graph here, and we're going to draw a graph. So I'm going to draw a little graph here, and then I'm going to draw a blue graph. Let's see if this is a function, right? So, well, it needs to pass the vertical line test. So for graphs, we want it to pass the vertical line test. We're not looking for repeated x values because we have a graph. So with a graph, I want to see. So if I draw a vertical line here, how many times does it cross my blue graph? Only once, right there. What about right here? Well, it crosses my graph once there, and here, once there. So no matter how many vertical lines I draw through my graph, it only crosses one time. So this is a function. It passes the vertical line test. The vertical line test might be long to write, so we'll just put VLT for vertical line test. Let's go ahead and draw a graph that's not an example of a function. Okay, an example would be a circle graph. Let's draw a vertical line to see if this passes. And I draw it through my blue graph. Does this pass the vertical line test? No, we only want it to cross once, and this has crossed twice. Well, what about right here? Nope, because it's also failing. So this is not a function. Fails the vertical line test. How does it fail? It crosses more than once, right? So if it crosses more than one time, it is not a function. Now let's talk about what it looks like for a table for us. So if we have tables, so we can have an x and y table, okay? And I'm just going to put some random numbers, so like 3, 5, 7, 8, and 10. Why not? And then I'll have 4, 6, 7, 9, 4. All right, so looking at our x and y table, when I'm looking at tables, remember, if I look back at my characteristics, I'm wanting no repeated x values. So if I'm looking at my x values on this side here, I don't see any that are repeating, which is great, because we don't want our x values to repeat and go to a different number. So this is a function. Now, if I add on to this table and I say, well, what if I have 5 and 6? Right, if I have another. Well, I do have a repeated x value. I have a 5 here and a 5 here, and it's repeating. However, it's still going out to 6. So it doesn't matter because it's just a duplicate. It's like a clone, and clones are okay. So this is okay. This is still a function. So it's a function, no repeating x values. So let's do a non-example. So I'm going to use the same numbers pretty much. 3, 5, 7, 8, 10, and 5. But this time I'm going to have 4, 6, 7, 9, 4, 8. Now this is not a function, and I'll show you why it's not a function here. Because, well, looking at our x values, we have 2 5s this time. This 5 goes to 6, and this 5 goes to 8. It's cheating, right? Or 5 is going to 6, but it's also going to 8. This is not okay. So this is not a function. Right? In the last one, the 5 was still going to 6 twice, which is okay. But this one's going to 2 different numbers. So we have a repeated x value. And if you want to even be more specific, we can talk about how it's cheating or how it's going to 2 different numbers. So if you want to say it, this is kind of just like, this isn't professional math terms, but if it helps you remember, 5 is cheating with 2 different numbers. Right? All right, so those are the characteristics of functions. So I'm just going to go ahead and go over that part first. All right, so let's go ahead and look at our notes. Our notes for today are continuous versus discrete and associated domain and range. So let's look at our vocabulary. Continuous, discrete, domain, and range. So I drew some graphs over there to kind of help you see what the difference between a continuous and a discrete graph is. Continuous graphs are one solid thing. You can draw it in one stroke. You don't have to pick up your pencil. You can draw that entire line with just one stroke of your pen. However, with discrete, I have to pick up my pen individually and plot those points. So if I have to pick up my pen, if it's different points, that's discrete. So for continuous, this is going to be an unbroken graph, or a continuous line or graph, whatever. It's continuous, it just keeps going. I don't have to pick up my pen to draw it. All right, with the discrete graphs, these are broken graphs, or broken graph, or isolated points. So they're individual points and they're isolated. So my 2 things. And I have some extra room down there because I do want to add some things later on. All right, our two next words are domain and range. Domain and range trip us up a lot, and I'm going to try to do my best to help you or help that process be really easy for you. So for our domain, we're talking about our x values. Okay, I just want to say that we're talking about x values here. That doesn't even look like a U. And what I mean by our x values is that's going to be all of our possible x values. For range, it's going to be our y values. So if you don't know, domain, we're going to be looking at our x values, which we're going to be looking at our x-axis. And for our range, we're going to look at our y values or our y-axis. So they're all possible y values. All right, moving on. So before we get into some domain and range with graphs and continuous and discrete with graphs, we're going to talk about word problems first. And don't freak out. It's just a sentence, and you just have to determine whether it's discrete or continuous and tell me why. So for number 1, the number of candy bars on a counter at Target. Now, to evaluate word problems or sentences or situations with continuous and discrete, we do have to mention one thing. Continuous problems are things that you can have fractions and parts of, right? Like, can you have half of a gallon of milk? Yeah. Could you have a quarter of a gallon of milk? Yeah. An eighth? Yeah. So you can just keep cutting it up, making more fractions and more fractions. However, can you have half of a candy bar? You can have half a candy bar, sure. But if I go to the store and I walk up to the counter and I say, hey, I'm going to rip this candy bar in half and ask you to buy half of it. I can't buy half of a candy bar. You can't do that. You have to buy the whole candy bar. So for continuous, you can have fractions or parts. So you can have halves of things, quarters of things. For discrete, you can only have whole numbers of things. So if we're looking at number 1 and we're looking at the number of candy bars on a counter at Target, well, when I'm at Target, there's not going to be half of a candy bar. I can't buy half a candy bar. So if we're talking about the number of candy bars, we can only have whole numbers. So this is going to be discrete. And just think about continuous means you can cut up into parts. So continuous, cut up, C's and C's. Discrete because you can't buy half a candy bar. You just can't. You can't buy half of one. You can only buy the whole thing. Number 2, the weight of animals. So let me highlight the important parts. The weight of animals. If we're talking about the weight of something, can I be 1.5 pounds? Sure. 3.5 pounds, 3.25 pounds. So weight, you can actually have fractions and parts of things. It's not like you can either be 5 pounds or 6 pounds. You can be anywhere in between. You can be 5.2 pounds, you can be 5.5 pounds. So since you can have parts and fractions of things, this is going to be continuous. Because you can, or let's say you can have half a pound. Number 3, the gallons of gas in your car depends on how long you've been driving. Now with these types of problems, we want to look at what it depends on. It depends on how long you've been driving. If it's depending on how long I've been driving, that means I've been driving for 3 hours or driving for 7 hours. So it's how long I've been driving. If I've been driving for 7 hours, that's how long, the time. So when I talk about how long, we're talking about time. So then I ask you, if it depends on time, isn't time continuous? Yeah, time doesn't stop for anybody, so it's always continuous. So this is a continuous problem because time is continuous. It never ends. It doesn't end for anybody, it doesn't stop for anybody. For number 4, the amount of money spent depends on the number of books you buy. All right, so this depends on what? Whoops, where's my pink? Go back to pink. It depends on the number of books I buy. If I buy something, if I'm buying books, I can't buy half of a book, right? I can't buy a third of a book. I can buy 1 book, or I can buy 2 books, or I can buy 3 books. I can't buy half of a book. So this is going to be discrete because you can't buy half a book. I'm sorry about the tapping, you guys. I'm really sorry. I'm trying my best, but I write pretty hard. All right, so those are examining sentences to determine if they're discrete or continuous. Now we're going to get into more math-related things. Not that discrete and continuous isn't, but more of graphs and functions and domain and range. So for the following, we're going to have to identify if they're functions, if they're continuous or discrete, and their domain and range. So number 1, we have a graph of this line, and we have to determine whether it's a function. Well, if I look back at the notes that I took at the very beginning, a function for graphs, I want it to pass the vertical line test. So let's do the vertical line test with number 1. If I draw a line through here, it crosses my graph once, or here, once, or once. So no matter how many vertical lines I draw, it passes. It only crosses once. So this is a yes. Passes the vertical line test, or VLT. Now I have to determine whether this is continuous or discrete. Now, remember, continuous means it's not broken. It's a solid thing, whereas discrete is individual points. This is going to be a continuous graph because it's a continuous line. All right, now we're going to get into domain and range. And I did say earlier that domain is your x values and your range is your y values. And I'm actually going to do that in a different color. Your domain, I'm going to do in red. Okay, now I'm going to go ahead. I have this giant space at the bottom, so we're going to talk about discrete or continuous domain and range for a second. So for continuous, for my domain and for my range, remember domain is what values? It's your x values. I'm going to ask you every single time on every problem. So for our domain, it's either going to look like this or like this, or a combination of those inequality signs, right? So you're always going to have less than signs, and the reason why you only have less than signs is because I want to show you only one way. If I show you lots of ways, it's going to confuse you, so we're just going to stick with one way, and that's just what it'll be. The reason why it is less than is because we're always going to look at our smallest value to our biggest value. Our ranges are y values, so they're always going to look like this or this. So that's for continuous domain and range. So if it's continuous, we have inequalities. For discrete, we have something else, and we'll talk about that. All right, so go ahead, and I have one more thing that I'm going to ask for you to write. I also have dollar robot. And those O's and those A's are lowercase. And here's why I have this. For dollar, I'm talking about domain. Whoops. And when I'm looking at domain, I want to look from left to right. So this is just a neat way to kind of remind you, hey, for domain, what do I look at? You want to go left to right. For range, you're going to look from bottom to top. So those are just some things to kind of help you out when you're looking at domain and range. All right, so let's do domain first. Again, domain is our x value, so let's go ahead and write an x there. And number one is always rough. It's rough because you have no idea what you're doing and you just need that practice. So we're going to do this as slow as possible. So domain, we're going to go from left to right because domain is dollar, so we go left to right. If I look at my left side and I'm looking at my x values, what is the most left my graph goes? Well, my most left point is here. So if I check, it's at -1. So my most left is at -1. Okay. And my most right, if I'm going from left to right, my most right is at 4. Okay, now I just have to put my inequality signs. Well, at -1, over here I have a closed circle. And when I have a closed circle, I have an inequality that has an equal to sign with it because it's closed. With my other point, it is an open circle. So I'm just going to have a less than. And that's it. You just have to fill in those numbers. For range, we have y, and you want to go from bottom to top because of robot. So if we start at the bottom, well, let's look at our circles first. So here at the bottom, I have an open circle. So you want to start from here and go up. From the bottom, I have an open circle, so that's going to give me a less than symbol. And if I go all the way up to the top, I have an closed circle, which is going to be equal to. So you want to go from bottom to top. Now at the bottom, my most least value is going to be 0 on my y-axis. And my topmost value here is +4. Again, it looks really weird the first time you do it, and it might look weird for a lot of times until you just get the hang of it, but you just need practice and more practice. All right, for number 2, is this a function? Well, let's look. For graphs, it has to pass the vertical line test, so let's look. Well, it passes the vertical line test here. It passes the vertical line test here and here. Oh, but it fails here. So I just have to find one spot that it fails. So this is not a function because it fails the vertical line test. Now I have to determine whether this is discrete or continuous. And this graph is discrete because it's isolated points. Okay? Now remember, isolated points or a broken graph means it's discrete. Okay, now we're going to look at domain and range. Now, domain and range for a discrete function is a lot easier to deal with than our continuous functions. So, if you want to make a note to yourself that discrete functions, or discrete domain and range, you just list the values. So it's a lot easier to find the domain and range for discrete. And we're going to talk about listing those in a second, but first let's talk about what we have to do. So do you remember back in like elementary school and you would draw like those sunset pictures and then you would draw like birds in the background and stuff? Well, our little things that we're going to use called curly braces or squiggle lines, they look kind of like the birds, except there's one extra little beak in there that looks like this. So we're going to have little curly braces when we list. Before we do that, we got to list our points here. So I'm going to go ahead and list all my points. So for example, this point right here is the point -4, -2. This point right here is -2, -1. This point right here is, or on this y-axis is 0, 1. This point right here is 1, 3. This point here is going to be 1, 2. This point up here is going to be the point 5, 3, and this point is 4, 0. All right, so these are all of my points. Now when I'm listing all my values, it's pretty easy. So I'm gonna go ahead and open up my curly braces here. So that's like our little bird, okay? So you always want to use curly braces. So since it's discrete, we list our values. If it's continuous, we use inequalities. So we're going to list all of our x values because domain is x. So I'm going to list all of my x values, and I like to go from least to greatest. So -4 is going to be my first value that I list. And then -2, remember all of your x values. We have 0, 1, and then I notice that I have 1 again. Now you can list 1 again, but you don't have to. I'm going to go ahead and not. It's kind of like saying your name twice to somebody. So it's not really important to write it 2 times, so I'm not going to. The next x value is 4, and the next one is 5. Oof. I am struggling a bit. That's okay. So I call them little squiggles because they kind of look like squiggles anyways. And then for our range, we're just going to list all of our y values. So you do the exact same thing, but now you're going to list your y values. And remember, when you're done listing all of your values, make sure you use the curly braces at the end to close it. So we have -2, -1, we have 0, we have 1, 2, 3, and then 3 again. So, whoops. Because we have 3, because we have 3 twice, I'm not going to go write twice, so I'm just going to write it once, and I'll be okay. So domain and range for discrete is pretty easy. You just list all of your values for x, and then list all your values for y. All right, number 3. Is this a function? Well, draw our vertical line. Does it pass? Yes. What about here? Yes. So anywhere I draw a vertical line, it will pass. So this is, yes, it is a function. It passes the vertical line test. Now, is this discrete or continuous? This is continuous because it is a solid thing. I can take my pencil and draw it in one smooth motion. That's how I was taught. If you can take your pencil and draw it in one motion, then it's continuous. But if it's discrete, like this last one, and you have to pick up your pencil to draw multiple points, that's discrete. Okay. Our domain here is always going to be what values? Our x values. So let's go ahead, we're going to put an x in the middle. And we're always going to have less than signs, remember. So domain, remember, is dollar. So we're going to go left to right. So we look at the farmost left value, which is going to be this guy over here. That's a closed circle, so we're going to have a less than or equal to because it's closed. And if I look all the way to the right, I have this point. That's also going to be equal to because it's a closed circle. Now's the fun part where I just have to find the numbers. Well, if I look on the very far left, if I look at what number that is, that's going to be -3. And if I go all the way to the right, that's going to be +4. And range is going to be our y values. So we have a y in the middle. And we always want to go from bottom to top for robot. So from the bottom, my most very bottom number is going to be this one down here, which is a closed circle. So I have a less than or equal to. And then my most top highest number is also closed, which is going to be less than or equal to as well. So it doesn't matter how funky my graph looks, you want to look at the entire thing. Where is the most bottom, where is the most top? All right, so looking at my most bottom value is going to be this one right here at -3. And then my most highest value is going to be at +2. And that's my domain and range. All right, for number 4, is this a function? And this is not a function because it crosses my graph twice. So this is not a function, fails the vertical line test. Is this continuous or discrete? It is continuous because you draw it in one smooth motion. All right, domain and range. Remember, domain is your x value, so I want to put x in the middle. And you always want to look at your farmost left, okay? Now, the farmost left is a closed circle. And a closed circle means I have less than or equal to. And then I want to look all the way to the right. And the mistake that most people make is that they stop right here. Well, you're like, well, if you're going to stop right there, then you might as well just erase the rest of this graph because you're pretending like it's not even there, right? But it is there. So just because there's a point there doesn't mean it's the farthest point over there. The farthest point on our graph is right here. Our thing stretches out all the way over there. And if you want to make a note to yourself, solid lines are closed. So my most far right is a solid line. Lines are made up of just a bunch of closed points, so your line is also going to be equal to. Okay? Now for domain, the farthest left value I have for my x is at -5. And the farthest most on my right is at +4. Again, this point, yes, it's a point on your graph, but it's not the farthest on the right. You want to go all the way to the right. Range is going to be your y values. And so you always want to start at the bottom. And at the bottom, I have a closed circle, so that's going to be less than or equal to. And at the very top, I have a closed circle, which is less than or equal to as well. Okay, now you're going to look at the bottom, and you go, well, what's my most bottom y value? That's going to be -3. And my most top y value is going to be +3. And that's it. Number 5, we have a function here, which is on a graph. Or is it a function? Let's find out. Let's draw a line. It passes. Here, also passes. Here, it passes again. So this is yes, passes the vertical line test. And this is also continuous. Now the thing about this that is different is that I have an arrow on one end. And when I have an arrow, that means that it never ends. It never stops. If it never stops or never ends, it has no ending, right? It can't ever be equal to anything because it just keeps going and going and going. So again, our domain is our x values. So let's go ahead and write our x values, x in the middle. We're going to go to the left to the right. So starting on the left, I have on the left an open circle. So this is just going to be less than, no equal to. And then if I go all the way to the right, where my x values are, well, it looks like it's getting pretty close to 2, but I think it's just going to keep getting close and close and closer to 2. It never touches 2. So if it never touches and never ends, then I also have a less than. It's never going to touch over there. It never equals anything, so it can't be equal to. And then I want to start on my left again for my most left number, and my most left number here is at -2. And my most right number on the other side is +2. So the line gets really close to 2, but never equals to 2. That's why we don't have an equal to there. And range is going to be your y value, so you have a y here. Okay? Now y, you're going to look at the most bottom to top. So you go from the bottom, you have an open, so you have a less than. And then if you go all the way to the top, is there ever a maximum number? Does it ever stop anywhere? No, right? This arrow means it keeps going and going and going. So there is no number, so we don't need anything over here. All right, so then we're going to start at the bottom. So our most bottom value on our y-axis is 1. And that's it. You don't need a number on the other side because there isn't a restriction. So there's a restriction on your domain because it only goes from -2 to 2, but on your range, it just goes from 1 to infinity pretty much. And you don't need to write an infinity sign because that isn't proper math language. All right, number 6, we have a table. If you want to make a note to yourself, tables are discrete. Why are they discrete? Because if you're looking at your table, it's only 5 points, right? If I asked you to graph what's on this table, you would just have 5 random points on your graph. You would have -2, 5, -3, 7, 5, 2, 7, 2, 9, 8. These are all random. All right, let's determine if this is a function. Well, with tables, if I look back at my notes, I'm looking for repeating x values. So let's look. Do I have any that are repeating? No, they're all different. So this is yes, it's a function, no repeating x values. Is this going to be discrete or continuous? This is going to be discrete because our table is isolated points, right? We have 5 random points. Now, because it's discrete, we get to list numbers for domain and range instead of writing inequalities. Remember, inequalities is for continuous. Discrete is going to be lists. So for domain are my x values, so I'm going to go ahead and list all of my x values. Make sure you have that curly brace. I have -2, -3, 5, 7, and 9. Then for my range, which is my y values, I'm going to list all of those values. 5, 7, 2, and I noticed that there's another 2, and I don't have to list it, but could you? Yes, you could list the extra 2, but I'm not going to. All right, number 7. Is this a function? No, right? It fails a vertical line test. It crosses at 2 different points here. So this is no, fails the vertical line test. Is this discrete or continuous? This is continuous because I could take my pen and draw around the entire thing without picking it up. So this is continuous. Okay, domain is our x values, so we're going to have an x in the middle. Now domain is dollar, so we go left to right. So like I said, solid lines are closed. So what is the most far left? Well, the most far left I have is a closed line. So this is going to be less than or equal to. And the most far right is also closed because it's a solid line, which is less than or equal to. So we have an equal to because there's a line there. Then you want to look at your most far left value. Well, your most far left value is at -4, and your farthest to the right is going to be +4. And then range is going to be our y values, and then you want to go from bottom to top. So our bottom, we have a solid line, which is going to be less than or equal to. And the top is a solid line, which means it's closed, which is a less than or equal to there as well. Our most bottom y value is -4, and our most top y value is 4. So it's actually the same thing as our domain. So sometimes they're exactly the same, and sometimes they're completely different. All right, our last example here is a mapping diagram. I do want to do an extra example at the very end, and it's just something that I'm going to show you. I'm not going to require you to write it, but I do want to talk about it because it is a little bit different from the one we have up there. And I'll talk about it later. So mapping diagrams are just basically a funky table. It's basically, instead of having a table, you have these weird line things. But what it's really saying is that I have the point 8,3, I have the point 8,6, I have the point 12 and 12, and I have the point 4,9. So basically, if you really wanted to write it out, you have this. Right? So you have a bunch of random points. So it's just a weirder way. But is this a function? I'm going to say no. And the reason why I say no is because 8 is going to 3, but 8 is also going to 6. 8 is going to 2 different numbers, so it's basically cheating. So you say no, repeating x value. And if you want to be more specific, the repeating x value is 8. It's cheating. It's going to 2 different numbers. Is this going to be continuous or discrete? This is discrete because it's just kind of like a funky table. All right, domain is your x values, and since this is discrete, I can list my values. So I have the point 8, 12, and 14. And when you're done writing your list, make sure you draw your curly braces at the end to close it. So our x values are there, and then we have our y values over here in our curly braces, which is going to be 3, 6, 9, and 12. Okay, now there's an example down here that I wanted to talk about because it's a little different from the last example. So I'm going to go ahead and draw this here. Okay, if I asked you to find the domain for this one, what would you say? You would go, oh, well, this is going to be 3, 5, 8. Okay, well, what would the range be? And you might say, oh, well, it's 1, 2, 3 because that's all my y values. However, do you see how nothing's going to 2? There's nothing pointing to 2, right? So 2 is not actually in your range. Your range would just be 1 and 3. Because 1 has stuff going to it, and 3 has stuff going to it, but 2 is all by itself. So 2 is not actually included. All right, guys, so that was a ton of information, but that is all about functions and discrete and continuous. If you have any questions, please feel free to come in and ask.